All right. Have you ever actually stopped to think about what's propelling your car down the highway at 70 miles an hour? I mean, we completely take it for granted, right? You just turn a key or push a button and go. But there is this absolute, fiery, mechanical magic happening literally inches from your feet. Welcome to the Explainer.
It really all comes down to a ridiculously simple but super violent concept. Every single time you drive, you are literally sitting on top of thousands of perfectly controlled explosions. No joke. This is what we call an internal combustion engine, and it's named that because the fuel combusts, or burns, right inside the engine itself. We take liquid fuel, set it on fire in a highly contained space, and just use the sheer force of that blast to shove us forward.
Here is our roadmap for today's Explainer. 1. The anatomy of an engine. 2. The four-stroke cycle. 3. Power reaching the wheels. And 4. Systems that keep it alive.
Okay, Section 1. The anatomy of an engine.
To really get how this works, we need to meet the main cast of characters in this mechanical symphony. First up, we've got the cylinder, which is basically a hollow chamber where the fuel actually burns. Inside that is the piston. Think of it like a heavy metal plunger that moves forcefully up and down. Sitting right at the very top of the cylinder is the spark plug, just waiting to ignite the fuel. Also up top are the valves, intake and exhaust valves, which act like heavy-duty blast doors to let air and fuel in and smoke out. And get this, these parts face unbelievable stress. We're talking combustion temperatures of over 4,000 degrees Fahrenheit. Now, controlling the precise timing of those valves opening and closing is a rotating shaft called the camshaft. And finally, sitting at the bottom of the piston, we have the crankshaft.
Now, the crankshaft is absolutely the unsung hero here. Think about it for a second. An explosion pushes a piston straight down, right? It's a linear vertical motion. But your wheels need to spin in circles. So how does that work? Well, the crankshaft is what turns that violent vertical bouncing into a smooth rotational spin. It's exactly like pedaling a bicycle. Your legs pump up and down, but the pedals and gears translate that vertical pumping into a spin that pushes you forward. Brilliant, right?
Moving on to Section 2, the four-stroke cycle. All right, let's zoom all the way down into just one single cylinder and slow things way down so we can see this continuous four-step loop in action. Step 1 is intake. The piston drops down, the intake valve pops open, and you can see that red air and fuel mixture getting sucked right into the chamber. Step 2 is compression. The valve slams shut and the piston pushes back up, squeezing that mixture incredibly tight. Step 3 is combustion, the famous power stroke. The spark plug fires, the highly pressurized mixture explodes in this huge flash of orange and yellow, and that violent force shoves the piston forcefully back down. That exact explosion is what actually generates your power. Finally, step 4, exhaust. The piston rises one last time, the exhaust valve opens up, and those smoky gray burnt gases get pushed out to make room for the next round. Basically, suck, squeeze, bang, blow. So the crazy part here is that this isn't just happening once or twice. This exact four-stroke cycle is repeating hundreds and hundreds of times every single minute, continuously, as long as your foot is on the gas. Seriously, at highway speeds, one individual piston might be firing 20 to 30 times a second.
But hang on, if you had just one single piston firing by itself, pushing down and then having to pull itself all the way back up for 3 dead strokes without power, your ride would be incredibly jerky. And that is exactly why engines have multiple cylinders, usually 4, 6, or 8 of them lined up in a row. By having multiple pistons fire in this carefully choreographed overlapping sequence, the engine turns those isolated, jerky explosions into a super smooth, continuous hum of power. When cylinder number 1 is on its empty exhaust stroke, cylinder number 3 is right in the middle of its explosive power stroke. So something is always pushing that crankshaft to keep it spinning seamlessly.
Which brings us to Section 3, power reaching the wheels.
Okay, let's pan back out and follow the journey of all that kinetic energy. It all starts with step 1, the piston's powerful up and down motion. And as we just learned, step 2 takes that vertical energy and translates it into rotational motion at the crankshaft. But here's the catch. That crankshaft is spinning way too fast to connect directly to your wheels. You'd lose control instantly. So in step 3, that rotational power enters the gearbox, or what we usually call the transmission. The gearbox acts as a mediator, constantly adjusting the speed and torque depending on whether you're accelerating from a dead stop at a red light or just cruising on the freeway. Finally, in step 4, that perfectly calibrated power flows out through the drivetrain to actually spin the wheels.
And finally,
Section 4. Systems that keep it alive.
Containing and actually harnessing thousands of fiery explosions every minute requires some serious heavy-duty backup. First up, the fuel system. It's responsible for delivering the absolute precise amount of fuel through the injectors. Too much or too little and the whole explosion fails. Next, the ignition system provides the electrical heartbeat, using the battery and spark plugs to create that spark perfectly on cue. But maybe just as importantly, we have the cooling system. This uses a radiator and liquid coolant to prevent the engine from literally melting itself into a puddle of slag under all that intense heat. Similarly, the lubrication system is constantly pumping oil throughout the engine, which drastically reduces the friction between all those high-speed moving metal parts. Together, cooling and lubrication are what keep this fiery metal box from totally seizing up. And lastly, the exhaust system safely channels away those burnt gases, knocking down both the crazy engine noise and the harmful emissions before they even exit your tailpipe.
To wrap up this explainer, I really want to leave you pondering the incredible, fiery engineering symphony that we just completely take for granted right beneath our feet. A modern internal combustion engine is an absolute marvel of timing, pressure, and thermodynamics, all working in this perfect overlapping harmony just to get us to the grocery store. It really makes you wonder, as we look to the future of transportation, what kind of mechanical marvels will be powering our vehicles 100 years from now? Whatever it is, it's going to have a tough act to follow. Thanks for joining me to explore the anatomy of motion today. Keep learning and keep wondering how the world around you works. To see more interesting and informative content like this, like, comment, and subscribe. Don't forget to press the bell icon.